So hey guys, welcome back to my new channel. So now I will summary the chapter 9 titled Transport Layer. This is the version 2.0 of our video. Transport Layer. Transportation of data. The transport layer is responsible for establishing a temporary communication session between two applications and delivering data between them. An application generates data that is sent from an application on a source host to an application on a destination host. This is without regard to the destination host type, the type of media over which the data must travel, the path taken by the data, the congestion on a link, or the size of the network as shown in the figure. You see in this figure. Masih siya the figure. Yeah. Transport layer responsibilities. Tracking individual conversations. At the transport layer, each set of data flowing between a source application and a destination application is known as a conversation. A host may have multiple applications that are communicating across the network simultaneously, segmenting data and reassembling segments. Data must be prepared to be sent across the media in manageable pieces. Most networks have a limitation on the amount of the data that can be included in a single packet. At the destination, the transport layer must be able to reconstruct the pieces of data into a complete data stream that is useful to application layer, identifying the applications. To pass data streams to the proper applications, the transport layer must identify the target application. Conversation multiplexing. Sending some types of data across a network as one complete communication stream can consume all of the available bandwidth. This will then prevent other communication from occurring at the same line. It would also make error recovery and retransmission of damaged data difficult. The figure shows that this is the figures. That's the figure that shows that the segmenting the data into smaller chunks. Transport layer reliability. The transport layer is also responsible for managing reliability requirements of a conversation. Different applications have different transport reliability requirements. IP is concerned only with the structure, addressing and routing of packets. IP does not specify how the delivery or transportation of the packets takes place. Transport protocols specify how to transfer messages between hosts. TCP is considered a reliable, full-featured transport layer protocol, which ensures that all of the data arrives to the destination. However, this requires additional fields in the TCP. TCP transport is analogous to sending packages that are tracked from source to destination. If a shipping order is broken up into several packages, a customer can check online to see the delivery. UDP. While the TCP reliability functions provide more robust communication between applications, they also incur additional overhead and possible delays in transmission. There is a trade-off between the value of reliability and the burden places on a network resources. Adding overhead to ensure reliability for some applications could reduce the usefulness of the application and even the detrimental in such UDP is a better transport protocol. The right transport layer protocol of the right application. For some applications, segments must arrive in a very specific sequence to be processed successfully. With other applications, all data must be fully received before any is considered useful. In both of these instances, TCP is used as the transport protocol. Application developers must choose which transport protocol type is appropriate based on the requirement for the application. TCP features. To understand the differences between TCP and UDP, it is important to understand how each protocol implements specific reliability features and how they track conversations. Establishing a session. TCP is a connection-oriented protocol. A connection-oriented protocol is one that negotiates and establishes a permanent connection. Reliable delivery. In network terms, reliability means ensuring that each segment that the source sends arrives at the destination. Same order delivery, because networks may provide multiple routes that can have different transmission rates. Data can arrive in the wrong order. By numbering and sequencing the segments, TCP can ensure that the segments are assembled into proper order. Flow control. Network hosts have limited resources, such as memory and processing power. When TCP is aware that these resources are overtaxed, it can request that the sending application reduce the rate of data flow. This is done by TCP regulating an amount of data the resource transmit. Application that use TCP. TCP is a great example of how different layers of the TCP or IP protocol should have specific roles. TCP handles all tasks associated with dividing the data stream into segments, providing reliability, controlling data flow, and the concurrent recording of segments. Application that use UDP. These are the three types of application that are best suited for UDP. Live video and multimedia applications can tolerate some data loss but require little or no delay. Excuse me. Simple request and reply applications. Application with example transactions where a host sends a request and may or may not receive a reply. Example include DNS and the DHCP. Application that handle reliability themselves. Undirectional communications where flow control, error detection, acknowledgement, and error recovery is not required or can be handled by the application. So for the whole summary of this chapter 9, the transport layer. The transport layer provides related services by dividing data received from application to segments, adding a header to identify and manage each segment, using the header information to reassemble the segment box into application data, passing the assembled data to the correct application. So the application developer decides the transport layer protocol that best meets the requirements for the applications. It is important to remember that the other layers all play a part in data network communication and influences its performance. So however, this does not necessarily mean that communication is unreliable to itself. There are many mechanisms and application layer protocols that services to not lose the data. So for this chapter, we learn about the UDP and the TCP, how it works like that. So that's all for my chapter 9. So please subscribe and like my video. That's all. Thank you.